Close your eyes. Don't worry, you won't miss anything. The slides are empty. Now you're standing in a desert. You feel the sand under your feet, the hot air in your face. You're walking. In the distance, you hear a humming noise. A humming noise of a large diesel engine. A diesel engine that belongs to an excavator. You look closely. The excavator is moving shovel after shovel of dirt from a hole to a pile. You look even more closely and you notice there's no one sitting in the cabin. No operator. No nothing. Now open your eyes. You ask yourself, what could potentially go wrong? This is the environment we operate in at Gravis Robotics. Most of you are likely used to a different kind of environment. An environment that has computers in racks. Something that looks like this. Computers in racks, rack after rack, aisle after aisle. That's where you deploy your infrastructure and your software to. What if I told you you only had a 10 megabit per second connection to your computers? Would you be able to deploy your systems, to monitor and to observe what's happening? Probably not. It's 2026 after all. We're used to fiber and gigabit connections. Yet we ourselves find often this situation. These are our computers that we deploy. That's where we deploy things to. We rarely have more than 10 megabit connections to them. The challenge gets worse than this. Once you start to add other factors like water and dust. Water that fries your electronics. Dust that ingresses everywhere into your cooling system. Horrible. Your hardware hates it. Once you also look at safety, you could ask yourself, is it safe? After all, your software is moving tens of tons of steel that just crushes everything in its way. All of these challenges I would summarize in a single question. I would ask all of you, are you confident in what you ship, both software and hardware? In robotics, we extend the software testing pyramid with 3 additional pillars to answer this question with yes. Pillar number 1, we add simulation. You want simulation in your continuous integration pipelines. If it doesn't work in simulation, it's not going to work in the real world. Trust me, we tried. Pillar number 2, hardware in the loop testing. As soon as your software works in simulation, you need to have it on the real hardware. That will uncover further failure modes that you haven't anticipated before. But last but not least, pillar number 3 and the holy grail is on-machine testing. You want to mate the real software with the real hardware in the real environment. Only once you combine these 3 together, you get the confidence to ship a robotic system reliably to a customer. So let's take a step back to where we started. The data center versus our use case. Both are computers, both are network connected. So I ask all of you, are they really so different than they seemed at in the beginning? I don't think so. As said, both are computers, both are network connected. We deploy software to them. So if we look at our use case again, with these servers slapped onto machines, it's in the end a computer that goes on a large excavator, big piece of steel, still a computer. But we engineers immediately are like, oh, this is cool. I want to play with this. I need to build my own tooling. I need to build my own stuff, right? Right? Yeah. Here's my plea to all of you. Do not reinvent the wheel. After all, what we're paid to do as engineers is we need to create value. We need to create value so we don't reinvent the wheel. Most of you probably care about business logic infrastructure. We at Gravis, we care about digging velocity and digging accuracy. That's our core values. That's what we need to deliver on, not the custom tooling. So I repeat it, all of you, do not reinvent the wheel. Use what's out there. Use what the DevOps community has created in the past and just reuse it. Even if your computer is in the middle of the desert, in the middle of nowhere, DevOps at that edge is still just regular DevOps. My name is Sandro. I lead the platform team at Gravis Robotics. We're hiring. Thank you.